Hey, good morning. Welcome to my talk Under the Hoods. My name is Michael Simons. I work as a staff software engineer at Neo4j. And in the next following 40 minutes, we're going to talk about Quarkus and GraalVM and a bit of Neo4j. It's a bunch of topics we have, so better get started. Just a quick slide about my employee. It's Neo4j from Malmö. It's the name of our company, and it's also the name of a very cool graph database. It's a native graph database. It's not a multi-data store. It has a dedicated native store for storing, retrieving, traversing nodes and relationships, and it's best, standing in the way of my stuff, best summarized with the small snippet of a Cypher query. That's our query language. So the product name Neo4j is created with love in Malmö, and a couple of other nice places like Aachen, this is where I'm from, and smaller cities like London. This is from our office. In contrast to some other tech companies, we are still hiring, and we have some nice engineering positions to fill. And that's about the advertisement. So why this talk today? They say knowledge is a dangerous thing, but it's less dangerous than ignorance. And today's Java application frameworks do a lot of magic all the time. There are a lot of context and dependency injection. They give you beans and collaborators out of thin air. If you put dependencies on the class paths, suddenly stuff happens. It's cool on conference day. You can get up a demo really quick. Second day, it might lead into trouble if you add additional stuff. Stuff behaves differently. Or in the case of GraalVM, you suddenly changes assumptions that you had on the JVM, for example, that you can reach out like everywhere, grab resources, grab methods, get classes, execute those methods, and whatnot. I think it's quite crucial these days to understand a bit more what happens in those frameworks. And this is true for GraalVM, this is true for Spring, and this is true for the new contenders like Quarkus and Micronaut. My background is actually, I'm a Spring engineer working at Spring Data Neo4j, so that is a whole new area for me, and I needed to learn that whole stuff, how Quarkus does things. And yeah, was an interesting ride. And what we want to do as a vendor here is we want to make the access to Neo4j, to our product, as frictionless as possible. I was too quick on the previous slide. We have a custom wire protocol with drivers for a broad range of languages like .NET, Python, and of course Java. And to make that wire protocol work, I need to do stuff like SSL. I need to have proper transports. I need to have proper byte buffers and all of that stuff. And we're using Netty for it. And that was our undertaking to deal and to learn about GraalVM and what it actually does. The reason for that. So anyone of the audience already worked with the GraalVM? So cool. Then I think I have some nice examples with me. So what is the GraalVM? These days, the rage is all about native image. And in contrast to native graph database, what native image means here is a natively self-contained executable for your operating system. So it's not like a standard traditional Java virtual machine. It's only a substrate of that virtual machine, and it's a self-contained binary. But GraalVM is also polyglot runtime, and it's also a language framework to build on top of the GraalVM. So it's a huge stack of technology. Yeah, that's basically in graphics taken from the Oracle slides. On the base of things is the GraalVM compiler. It's a highly optimized compiler, way more optimized than the C2 compiler, sitting on hotspot. And it takes input from the language implementation frameworks with a graph-based approach actually, and makes it possible to run your standard JVM languages like Scala, Kotlin, Java, but all that other stuff above there, JavaScript, Ruby, R, Python, which makes it quite interesting, because those languages seems to be, at least that's what Oracle and GraalVM proof in their benchmarks be faster than their original implementations. Slides can tell a lot. This is actually a fully functional GraalVM polyglot program. So you see it's a Java class. It's a public class with the ubiquitous main method. It's modern Java. I'm using the var and the text blocks. And inside that text block, there is a small JavaScript program. And in that JavaScript program, I make use of the GraalVM JS implementation. I can grab a Java type again, so I can reach back to my host, grab content from the host, and execute it here to get the local date. And the line in the middle is actually original JavaScript JSON processing. And GraalVM allows this stuff to be executed in Java and also natively. I'm gonna run this in a second. So we have two modes of executions. We have the standard JVM mode that behaves very similar to what your normal JVM does. It has the same characteristics. It has a warm-up time, gets faster over long runtime, has slightly less predictable memory characteristics, but it's the same but with a different compiler, right? In native image mode, this assumption does not apply. It has a very fast startup time because the whole initialization, the whole class initialization happens during build time, including all the needed JDK classes, all the dependencies, and of course the application code. This is a thing that's quite hard to get right. Java has lengthy specification how to initialize classes and their ancestors and inheritance, the static code blocks and all of that. The first GraalVM versions did everything on build time, so that made it really hard, at least for us, to figure out what's going on with our driver, with the embedded netty code, because you compiled it and you got like a gazillion lines of stack trace of initialized classes. So was interesting. That shifted. GraalVM is not that new anymore. It has like, the first time I heard this was 2017, so good chunk of 5 years. It shifted now to runtime initialization. But that does not mean it's not a closed world. When I build a native image with GraalVM, it still tries to figure out what classes, what methods are reachable. So this is a graph that is closed at compile time, but the initialization, god damn it, it's a hard word for me, sorry, still happens at runtime then. There are a bunch of classes that is always build time initialized, such as the JDK classes, including the garbage collectors. There are save classes that are all the classes that are only inheriting from other save classes, not doing native calls into the system, and explicitly listed classes. So you get basically a working compromise of having super fast startup times and better developer experience. So let's jump into a quick demo. This is not readable. I learned some tricks yesterday in that presentation. That's the wrong EDA. Perfect. In that great NetBean IntelliJ presentation yesterday. Yeah, this standard Java program, I can just run this, and you see at the bottom it just runs. I didn't compile it here. I used the single source file feature of modern Java. To make it run with native image, I first need to compile this into a class file, and then I can instruct native image to build a binary for me. So this is just a these most simple hello world basically you can get. It's a quite powerful machine that I have here, but still it takes like 14 seconds without the battery plugged in. And there's actually a ton of stuff that is already in the image just by using a simple system out. So I have this later on the slides, but I have to get this out now. Some of the talks about GraalVM is about making IT a bit greener and more sustainable. I highly doubt this because for 4 years now, developers try to get this stuff right and have been complaining native image like crazy. I think there's some, yeah. There needs to be a lot of potential to save there to make up for that. So running this now gives me the same result. It does not stay as easy as that. If we jump into a second example here, it's basically the same program. It has two methods, greeting1 and greeting2 at the top, one the English version, one the Swedish version. And in line 8, I'm gonna use some input parameters to decide which methods to call, and I default to greeting1. So if I run that program on the JVM, I can greet you in Swedish. That works quite nicely. And I did all these thens to trick the native image compiler to not analyze my use of reflection, my magic incarnations. So if I would have written get declared methods and the string constant, the native image compiler is smart enough today that it figures out which of the methods to call. If I create a class file from this right now and run native image naively on it, it does the same dance as before. Some stars, some analysis, and now it yells at me that the reflection method, that I'm using reflection, some magic, and it's building a standalone image here due to the use of reflection without configuration. And you would be surprised how much reflection happens in all of the libraries being used. But in contrast to rumors, GraalVM can deal with reflection and just need to configure that. So simple approach would be, what does it tell me? Use no fallback here. And when I run this binary with the parameter greeting2, it rightfully yells at me because the thing is not there. I assumed that I have an open world. GraalVM says, no, you have not. You have a closed world. This stuff is not in there. You have to enumerate it. I can do this manually, but I can also use a so-called Java agent that is built in the distribution of the GraalVM. And I can orchestrate it. It runs. And what it creates is a bunch of JSON files. No, not the resource config. It's the reflect config here. And it basically does what we did all the time in the frameworks, in Quarkus, in Spring, and I think in Micronaut does it to some extent as well. It enumerates stuff that is going to be used in my image. And I use this now to build that native image. I think that's the right one. I should have played some music while compiling stuff. It just takes 10 seconds out of your life. I'm sorry for that. and now I can use the native version of it. So what do you think happens if I use the greeting one? Exactly, no luck. I see shaking heads. That's correct. So if I do this, it's uttermost important that I get the instrumentation right, and I have a decent test coverage if I use the agent to build this. In that case, I would basically need to edit second methods to there. So just relying on the agent can bring you into brittle situations. So proper test coverage is really important, and all of the frameworks, including Quarkus and upcoming Spring Framework 6, will help you with that, so that you actually can run your unit tests in native image mode. But again, that will take more time than it used to do. So I have the last example here, the hello.js. Like I said, it's an example of the Cool. It's a nice example of the polyglot capabilities. The source highlight I learned yesterday, I have language injection in IntelliJ if I specify the language here, which I find totally awesome actually. I'm not gonna run this through native image because that will really take some time. And you see I have the greeting here with the current date. Got it from JavaScript inside Java from Java methods, and that's what you can do with GraalVM. And I know people who are actually building stuff of it. One is competitor of ours, it's Oracle. They're having GraalVM native image JavaScript engine in their database, and they're combining all that stuff. One is a partner of ours. They're building also a low-code tool with it, and it runs on Java and allows people to execute JavaScript on it. If you run this through native image, you get quite some big images here. This is the JavaScript example here is 140 megabytes big, and it's only the hello world. What it includes is the substrate VM plus the truffle implementation of JavaScript and like the 10 lines of code we've written. So that was like 15 minutes already of native image time. We had the example that we need to take care of the closed world assumption. Short break. Now to the other topic. Any one of you already worked with Quarkus? 4 people. Cool. So the question I had shortly before the talk, would I recommend Quarkus? Let's see what the Spring guy says about Quarkus. Quarkus made its first appearance back in 2019. At that time, I was at a conference in Germany presenting how to use Neo4j. It was a really focused Neo4j talk, and I had demos for all kinds of framework, and these guys appear with a big marketing splash, and I wanted to include it. I wanted to go with the flow. Nothing was working because all of the bytecode optimizations, I hated it. But frustration can be tailored to something good, and I learned what it does. So it's basically your Java application framework. You have CDI, you have unified configuration, and all of that. But it's way younger than the 20-year-old Spring framework, and they started it with the container-first approach. So everything in this thing is meant to be run as a image in a container runtime, including super fast startup to proper scale, and that works actually quite well. And the goal is to have Hotspot and GraalVM on par. So you can use Quarkus without native image all the time. And I'm actually doing that because I'm too lazy to native compile for my personal enjoyment. So what you get is also live coding. So there is a enhanced class loader that checks your source files. There's a plugin for Maven and Gradle. It recompiles them, and in dev mode it helps you to assess what you have in there, kind of beans. And what I like is a vendor wirklich God damn it. I noted the typo on my slide, and sorry for the blackout. As a vendor, I love the fact that it's based on, has support for test containers. Test containers is a Docker-based technology that allows to bring up databases, message brokers, Kafka, inside a container from your applications, and that works very well. I'm going to show you in a second. So at the time of creation, the GraalVM was also doing only build-time initialization, and Quarkus followed that approach. Everything that is in there was done during build time. Configuration, beans processing, resources, entities like for Hibernate or for Neo4j OGM, and that they're doing this for both the JVM and the native modes. So the challenge of the assumption that there is not an open world in the JVM applies to the JVM mode of Quarkus as well. So that was a combined learning for us. And what they're doing is they're building a lot of synthetic bytecodes doing compilation. Yeah, briefly mentioned already the challenges, goals for our connectivity. We are dealing with persistent TCP connections for the custom wire protocol. For our object graph mapping, we need to discover entities, annotate the classes. We need to get hold of the fields of the methods to properly map them into our graph. We need to get hold of the unified configuration to initialize the connection. Yeah, and our boss fight was actually the SSL support. It was not for the faint-hearted to get SSL in native image correct. This is solved now. There's one switch you can turn on, and it's on by default, and SSL is working in native image. It's kind of great. Yeah, I already had this assumption about a closed world. For doing so, there's a bunch of different options in the frameworks. When you think of your typical Spring application, you see a bunch of annotations, and it's everywhere. It's in Hibernate, it's in Neo4j OGM, it's in Quarkus. Most of the time, the frameworks deal with those annotations during runtime. That's, I think, basically what most Java developers out there think of annotations. But there's proper package inside the JDK, Java X annotation processing. All that stuff happens during compile time, and it's a great API. I mean, it's not the nicest API under the sun, but it's fully functional. You can do all kinds of stuff with it that you can't do on a JVM. Like, for example, you don't suffer from type erasure during annotation processing because it's still there on compile time. You can properly deal with typed lists and map and what have you. And from there on, you can diverge into source code or bytecode generation. Quarkus decided for bytecode generations. Modern Spring Framework decided for source code generation. That will see the light of day in December this year. There are, of course, means to programmatically interact with the GraalVM. There's an API for that, to substitute classes that may not work with native image, such as various encodings in Netty. We used that for a while. But that's kind of brittle in case you have a driver that's supposed to work with many different frameworks on many different versions of GraalVM these days. Kind of brittle. I wouldn't go there anymore, actually. And the frameworks itself provide, all of them again, functional extension points, either through API or through annotations that are meant to be hints, like include that class for reflection. So, and the people providing extension for Quarkus, they basically go with annotations. Now we're finally under the hoods of a Quarkus extension. This is what you see in my IDE for the Quarkus Neo4j integration. Stuff consists of 3 main modules, the deployment module being already highlighted, the runtime module, and hopefully some integration tests. I think all of them have it. As a consumer of that extension that provides you with connectivity into Neo4j, you will depend on the runtime module and only on that runtime module. The plugin system or the build tool, the build plugins of Quarkus will then in turn read some metadata of that extension and grab the highlighted deployment module. You will never have it the other way around, because if you do, you will grab all the dependencies of Quarkus build setup into your applications, and you don't want that. I think it will work and it will even compile, but there's no point in doing so. Then the augmentation will happen during build time. There will be some static initialization and some runtime initialization. And that's kind of nicely done. All the build steps necessary for your extension will happen in the deployment module, and they can, it's like days of future past. They can hook into the runtime that is not running yet because it's build time, and use so-called recorders to create a blueprint of that stuff that should happen. And I'm going to show you this right now. Break all the things. Oops. Let's see if I get the right IDE this time. That would be this. So, as you see, I'm in the deployment module of my package. I'm a bit lying here. That is the extension for the whole bunch of stuff we offer as a company. This is for Neo4j OGM, the object graph mapper. And this is part of the deployment. And it basically reads like a storybook or blueprint from top to bottom. I first declare a feature that is supported by this extension. This build step is a fixed build step happening now. The next build step is about finding annotated classes. In all of the build steps, extension providers like me can depend on other extensions or built-in providers. Quarkus makes it really easy to get hold of enumerated classes. This is the index of all the classes. And basically, there's some predicate searching for annotated classes here, the node entity and the relationship entity. And this happens during build time and avoid all the slow startup that you have, for example, for Hibernate. Hibernate in Quarkus works the very same way. They're going one step further, they're doing this, and they actually bring up the entity manager for Hibernate and write that state to bytecode. The result set of such a build step can be void, then it just interacts with the context, or in this case, another build item, that's going to be the list of classes. I need them to process them later on. Skipping a bunch of helper methods. And this is where it gets directly connected to GraalVM. I pass on a build item from the previous build step and tell Quarkus to instruct GraalVM, hey, I really need those classes during runtime. This is what we've seen in the reflection config. I have API for that, so that's the whole stuff. Same but different, something we load by reflection on default. Same but different, we want to have a custom index. We can generate resources during build process. Nothing to be done left in runtime. So that's not native, but it's a closed world assumption that make your startup really fast. And a lot of the development, not only in Quarkus, goes into that direction to optimize your startup times. It's not only about native image, but native image gave a whole kick for that different assumption. I'm going to skip the next non-runtime build step and just go to the last one here, because in this one we're going to interact with a recorder. So this needs to be explicitly being a runtime build step. This needs to be marked. Build time build steps are the default. And I need to inject a recorder. I have to provide those recorders. Jump to this in a second. And I depend on a bunch of other build items, such as the Neo4j driver itself. This is where the native image stuff or effort has been put into. The extension is more boring than this one because here I have scanning for resources and all of that. I take the entities that I've found before and take all of them to my recorder and initialize my Neo4j session. So now I'm in a different module. I'm in the runtime module. This needs to be on the runtime as well. This is the method I was calling from the processor. The code is not that important. That's just the dance that is needed for creating Neo4j OGM entity mapper. Especially this line is important. This is where a database connection will be opened. I want to shut this down when the context shuts down. But this is called during build time, and the output is bytecode. No execution in real life. And that's basically the whole trick of Quarkus. And I have a bunch of minutes to show this in action. And I'm going to use our integration tests for that. Because there's some weird interaction. I'm going to use our integration tests for that because it gives you an impression what's possible these days in the frameworks end to end. So I don't have Neo4j running on my machine right now, but I have a working Docker environment. And what you see here, damn it, too fast. It's gone, cool. I think that was in that line, where is it? It waited for the Neo4j Docker extension to start. It's spit out to the left the URL where I can reach out Neo4j. And then it, of course, Quarkus has a banner as well. It did the processing. And basically that was it on this machine in 7 seconds, including a Neo4j database. So 7 seconds sounds like a lot. I get this, like in the other demos, they only have milliseconds. But bear in mind, I brought up a Neo4j database, 7 seconds, including everything. You can jump right in here into the UI of the whole stuff. It tells me resource not found. I think this is a bit small. But it already tells me, hey, there's some API with movies and some API with people. That's kind of nice. Let's see if there's something in it. No, it's just empty. We can change that. We can jump into the development UI of Quarkus. This stuff is built in as well. And I didn't have enough time to show you the hooks to get something like this. This is our tile. This is our tile, and this is our tile. And this is really easy to build on your own if you want to provide custom extensions. And what we offer here is access to the Neo4j browser. This is the web shell of Neo4j, in which you can create things. Yeah, you could browse your nodes in here. It's nice. Going back to the development UI, I see some stuff that is called Neo4j migrations. This is stuff we offer, something like on the lines of Flyway. Probably you've heard of that, database refactoring, something controlled environment to offer step-by-step migrations of a database. I can run this from here. This is interesting for the same reasons, because it uses resources that are dynamically available in the applications. The resources can't be there all the time doing compilation, because you might want to point it to some resources lying somewhere else. That works as well, so you can have basically configuration that is build time only, but can be added on top for runtime. This is such a case where I don't maybe not have everything in my hand right now. So if there's some test data in it, and now I could actually grab our movie graph or go back to the UI and I see some proper graph in it. Yeah, and for completeness, the available entities here, such as actor and movie and stuff, those are the classes that have been found with the code previously. Like, we've been looking for classes annotated like this. That would be all for the demo. To recap all that, I talked like 35 minutes about flags and hints and configuration, and this is my commit of the year. I will be able to delete 500 lines of code from our Java driver, and I'm really happy about that. That is due to the fact that GraalVM these days defaults to runtime, and we kicked out all the stuff we needed to make this work. So quite happy about that. The stuff that remains will be pushed to the Quarkus-Extensions, and in case anyone builds their own extensions, I would follow that lead. Go with Runtime-Initialization in your driver or connector or what have you, and do the necessary thing outside that approach in that thing that behaves differently. That makes your life a lot easier. Yeah. This is an opinion, relevance to the ecosystem. I think the last 4 years were quite right in that area. Especially the fact that Quarkus challenged a lot of assumptions. I didn't say it up front. I'm really a Spring guy, and at some point you get a bit drunk from the Kool-Aid. And if you only stick in that ecosystem, you think it's the best and greatest, and whereas some things might be optimizable. And that was a really needed breath of fresh air, and I think the upcoming Spring Framework 6 will be excellent. There went a lot of effort into this. I have this on the slide. They're going a different direction with the bytecode generation, and they took a long time to get this right, and I think it was the right decision. As a vendor, it can get a bit hard to have your database drivers optimized for that in all of the frameworks. So I don't have any preferences these days. I want to have good connectivity in Quarkus, Spring, Micronaut, Helidon, and plain Jakarta EE if you so want. So that's my challenge here. Yeah, that's a bit harder than like 4 years ago. Yeah, and leaving you with the why. Faster startup times is a big factor. If you have big cloud deployments, if you want to save money, you want to scale to 0. That has not been that easily with pure JVM mode. This can be a reason to do this. If you want to run this in Lambda, can make Java feasible for Lambda. It's probably a bit more secure. I mean, we had quite some fun the last year, since we had log4shell, we had Spring for shell, and last month it was text for shell. So it's getting better with all the lookups that are possible with reflections in log4j, in Spring, and commons text. This is not possible by default when you run a native image. You need to explicitly open for it by default. So can be more secure. My personal thing is I really love this because I can build proper CLIs with Java. Nobody wants to install a JVM if I want to give away our Cypher shell. I need to always tell people, hey, you have to install JVM. Windows people hate this for whatever reason. If I can give them a native image, it's cool for me, it's cool for them. And also it starts fast. And it doesn't suffer from being a bit slower in the long run, because usually CLI comes and goes, and that's it. Yeah. I say tak for being here, and You find some links, some rambling about frameworks, tooling, about GraalVM, and if you're interested in what I'm doing, this is my GitHub profile. If you have questions, I hang around, and feel free to ask me. Thank you.